Why roller coasters don't fall when they are at the top of the loop. So at the top of the loop of the cart has a force of gravity that points towards the center of the loop, right? And there is nothing really holding it up here pointing in this direction. I am assuming here that there are no fancy wheel contraptions holding the cart so that even when it's upside down it doesn't fall. I'm saying purely imagine this was a Hot Wheels track, right? How we can calculate how fast the cart has to go in order to not fall at the top of the loop. And this becomes just a circular motion problem. So from circular motion, we know uh, that centripetal force is equal to mass times velocity squared over r. In this case, the only force pointing towards the center is mg, weight or force of gravity. So I'm just going to rewrite this as mg. We have mass cancel on both sides, so we can calculate our v, or our minimum speed at the top required, to be square root of g times r. So this gives us the minimum speed at the top of loop. All right, let's go ahead and do a quick example, a similar example of this. We have a roller coaster, loop is 10 meters in radius. Find the minimum speed needed at the top so that the cart doesn't fall. So as shown here, the only force acting on the cart at the top is gravity. So, and we know that gravity is equal to 9.8 meters per second squared. We are given radius of 10, and we just calculated that v is equal to square root gr. That is how to find minimum speed. So v is equal to square root of gr. Again, this is our minimum speed needed. So now I'm going to substitute everything into the formula. So we have v is equal to 9.8 times 10, which is just square root of 98. So v is approximately 9.9 meters per second. So in other words, the coaster or the cart must move at least 9.9 meters per second to not fall at the very top of the loop. And that is why roller coasters don't fall in loops with simple circular motion and simple physics.